Okay, then we have that component is from this our digital oscilloscope. Let me use channel 1. So channel 1 as indicated its output from here. Then by adjusting this voltage per divisions, we can get some signals by using this component. Here, to make this frequency adjustment, we have, in addition to that, use time variations. By varying the time values, we can get different output signals. So the signal's speed will be determined by using our times range. Here, as you have seen, I have used around 500 milliseconds. This 500 milliseconds will be almost indicated on this one, and the signal output speeds will be then in accordance. When I almost make the output or the time adjustment to 10 microsecond, almost you have seen another signal values. So you can, by adjusting the time or the x-axis values, you can get some different signals like this one. Still my voltage is common, it is around 200 millivolts. That is what I have adjusted. So by using even the voltage amount or by reducing the voltage amount, you can get the signals. So where this one is, this line is x-axis, almost this line is called y-axis. So the signal output will be plotted on this one. Let me check in this one. This signal is almost the AC input which the oscilloscope has almost empowered with. So I have to check first this signal output. So the signal is AC, almost voltage per division is almost assigned. My voltage per division is 100 millivolts. My time per division is around 10 microseconds. So the frequency is obtained from that one, because we can get the frequency from the full spread. That means one full spread is called the inverse of frequency. So frequency is the inverse of this spread. So spread can be calculated from this one. So here we can calculate the maximum voltage from this one. Here is 0. From these 0 values you can get by adjusting this one. Let me make this one. This signal is almost can be calculated from this one, almost from 0 to 1 and a point something. Below there is 1 point something. So peak to peak voltage means the voltage magnitude. Here is a voltage magnitude of the voltage. The magnitude of the voltage is almost calculated by peak voltage multiplied by 2. That is called peak to peak voltage. The other one is from this 0 to here, you can calculate about the time matters. So there is almost around 5 intervals. So one full cycle is tapped from here, 1, 2, almost if it is 2. So you can use 110 millisecond times 2 around to 200 milliseconds divided by 1000 to convert into 2 seconds, you will get around 0.2 seconds. So the signal will be started from here to ending from here. It requires 0.2 seconds. So from these second intervals you can calculate about the frequency. Here the voltage is also calculated from here. That is 100 millivolts times almost this is 6 multiplied by 6, that is almost around 600 millivolts. This 600 volt will be converted into volt around 0.6 volt. So it is peak voltage. To get peak to peak voltage, you can multiply that around 1.2 volts peak to peak voltage you have. So this is how to calibrate digital oscilloscope. It is another issues we have to consider in instrumentation and the control device. Now, this signal is generated from the internal part of our oscilloscope, so oscilloscope can be read such signals. Generated signals from signal generators or from other load. That is our third video's part. Thank you.